I'm going to talk about the different types of rocks in Pyrenees. Let's begin with the first categories. The magmatic rocks, which are separated in two categories. The extrusion rocks of volcanic, for example, basalt. On the east, intrusive rocks like granite. The magma collided in two different ways.
The first category was formed from magma which fast cooled off following the eruption of a volcano. These types of rocks stay under the ground. The second category was also formed from magma which slowly cooled down.
The second family of rocks are the sedimentary rocks. It is separated in two categories. The clastic, particularly, for example, clay and sand, it was created with the rest of all the rocks. The second type is the biogenic particle. It was composed by organic particles. We can find them in all our basins.
And in this end, we can find another rock family, the metamorphic rocks. It's separated in two categories, the contact metamorphism, for example Hornfels, and the regional metamorphism, like marble, created from any type of rocks, whose name is country rocks. They were exposed to high temperature or pressure or both. They changed into a new rock. We can see this phenomenon in the subduction zone and in the mountain range.
In fact, we can find the three types of rocks in the Pyrenees. We are going to see with a sketch.
First, I'm gonna draw a mountain. Here, the root is the consequence of the isostasy. I draw the magmatic chamber. It represents the magma using green crosses, which is intruding, coming from the mantle to the crust. Its height is between 8 and 10 kilometers. The pink highlighter represents the sedimentary rock. The low pressure and high temperature, 800 degrees, become an aerial metamorphic rock named Hornfels.
Hi, I'll introduce myself. I'm Hornfels of the metamorphic rocks family.
I was a magmatic rock.
Like the granite. If you look at me closer, you'll see two different colors. It's because I've cooked 2 times and not one like the other rocks. This phenomenon transformed the composition of the first rock to create a new one. We cooked between 7 and 800 degrees. Ordinarily, I'm composed by granite and mica. I have a granular texture and my colors are generally gray or black. But the chemical composition of our density of the member of our family can be very different because of our different formations.
The magma cooled down and became granite.
Hi, I'm
a magmatic rock.
See, I'm ochre, but in the granite family you can find grey rocks but also pink rocks, like in the pink granite coast in Brittany. If you watch me closer, you should see black and white dots. It's due to the mica, white or black, and the quartz, the white dots, which are crystals. My underground color is decided by the feldspar. I'm composed of 47% of O2, 32.7% of silicium, 7.6% of aluminium, and 4.11% of potassium. I'm an ingenious rock. You can find me everywhere in the earth. We're gonna see why later in the video. Generally, the density of my family members is 2.7, but it can be between 2.4 and 2.8. Now we are going to see my sedimentary friend. See you!
Around of these wave sedimentary rocks.
Hello, nice to meet you. I'm a limestone. Can you see how I'm built? No? Can't you see the thin strip which compose myself? Okay, now that you can see them, I can explain to you the cause of their presence. So, these stripes are sediments. It can be organic sediment or mineral sediment. Therefore, our chemical composition can vary a lot between one rock of our family to another. Our density too. For example, me, a limestone, I have a density of 2.7. We are all created by this phenomenon: weathering, erosion, transport, deposition, precipitation, and lithofaction. My family covers 90% of the Earth's crust. My chemical composition is 53.16% of carbonate calcium and a lot of other molecules.
Nowadays, all these rocks outcrop under the action of the erosion. We are happy to have presented our family. Bye!